Check, check. Okay. Okay. Hello everyone. Welcome to the OneClass channel. My name is Andrew, and I'm a student doing statistics and mathematics at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school level and college level. And if you need some homework help or tutoring, check out the links in the description below. So now let's start our session. Okay. So our first question today. Let me just copy down the question first. So, classify the triangle. Check O that apply. And our choices are equalero, right, obtuse, acute, scalene, and isosceles. All right. So first, let's define what these words mean. Okay. So first, let's define acute. So acute. Oops. Okay. Just 3 acute angles. It has to be less than 90 degrees. So an examples could be this or this. As long as we make sure each angle is not over 90 degrees, it's fine. And then for obtuse, some examples could be this or like that. We need to make sure that one angle is greater than 90 degrees. So in the examples I gave, this angle and this angle is over 90 degrees. All right. So, and for scaling, it just means all 3 sides has different length. So it could be something like this, or that. And for isosceles, that means 2 sides of equal length. So the shapes will look like this. So let's say side A, side B, and side A is equal to side B, and it can also look like this. Oops. A, B, and these 2 are equal. Yep. So by knowing this, we can tell our answer should be A, E, A, D, and F. And let me just copy down the original graph, the diagram. So they have the same length. Yep. Okay. So from this figure, we can see that all 3 sides of the triangle have the same length. So that's the first insight. All 3 length have the same. All 3 sides. Same length. Yep, so that's the first thing. And also, all three of its angles are equal. So we consider this triangle as an equilateral triangle since the total internal angle of a triangle is 180, and we can deduce that each angle inside the triangle is equal to 60 because 60 times 3 is 180. Yeah. And since we also got the 60 degrees, it also follows the definition of acute triangle. So this triangle is also a acute triangle. And we can also consider this triangle as an isosceles triangle because at least two of its sides have a equal length. Because we have A is equal to B is equal to C. So our answer will be A, D, and F. Alright, so let's leave a comment there. A, D, and F. Good job. Correct. Alright, so coming up, we need to solve the compound inequality. Solve the inequality which is 6b smaller than 24 or 4b plus 12 is greater than 4. Right. So as you can see here, we have two parts. Let's call this part 1 and part 2. Right. So first let's solve for part 1. We solve for part 1. We got 6b is smaller than 24. So we times 1 over 6 on each side to get rid of this coefficient of b. So we got 1 over 6 times 6b is smaller than 1 over 6 times 24. And 6 over 6 will be 1. So it becomes 1b is less than 24 over 6. And 1 times b is just b itself. And 24 divided by 6 is 4. Yep, so that's what we got from the first part. And for our second part, so for part 2, we got 4b plus 12 is greater than 4. Alright, so since we want to have b only be on one side, so we move the 12 to the other side. So in order to do this, we will minus 12 on each side. Minus 12, 4 minus 12, and plus 12 minus 12, it just becomes 0. So we only got 4b on the left hand side, which is greater than 4 minus 12, which is negative 8. Right. So similar to part 1, we times 1 over 4 on each side to get rid of the coefficient of b. 1 over 4 times negative 8. And 1 over 4 times 4 is just 1. So we only got b on one side. And negative 8 divided by 4 is just negative 2. Right. So that's what we got from the second part. So now we just need to combine the both inequalities. Combine the result from part 1 and 2. We have b is less than 4 or b is greater than -2. And if we represent it on a vertical line, it will somehow look like this. So that's -2, and that's b. We want b is smaller than 4, so that's this area. And we also want b is greater than -2. Which is this area. So we can conclude that b is less than 4 or b is greater than -2 is same thing as -2 smaller than b is smaller than 4. So which means b is greater than -2 but less than 4. Yeah, and I think that's all we got for this question. And let's leave a comment there. Okay. So here we have our next question. It's asking us, what is the formula for the area of a trapezoid? Okay. What is the area of a trapezoid? All right. So first, let's define what a trapezoid is. Okay. So a trapezoid is a closed shape with 4 sides with 1 pair of parallel sides, and the parallel sides are known as the bases, and while the non-parallel sides are the legs of trapezoid. And let's draw a graph. Yeah. So let's call this h, which is stand for height, and that's area 1, area 2. And that's B1, that's B2. Okay. So as you can see here, B1 and B2 are the pair of parallel sides, and this is also known as the basis. And the non-parallel lines are, in this case, let's call this C and D, which is this part and this part, and those are what we call the legs of the trapezoid. All right. So by knowing this, we're looking at the above figure, and we can see that the area of a trapezoid is a combination of the area of a triangle at the center and the two right triangle on both sides. So that's let's see, area 1, and that's a rectangle, and that's area 3, which is another triangle, and all this can form, say, trapezoid. Okay. So we can represent the area of trapezoid as the area of rectangle plus the area of the triangles. Remember there are 2 triangles, and now we'll have to use a formula for the area of a triangle, which is given by So this part is just equal to length times width. And the formula for the area of a triangle is given by triangle is equal by 1/2 times base times height. All right. So for the rectangle in the given trapezoid, the length and the width are the height and the base B1 of the trapezoid. Therefore, the area of the triangle at the center of the trapezoid is, so now we're calculating, we'll use another color. So for the orange area, we know that the base is just B1, and we also have our height, which is H. So this part is also equal to B1 times H. So that's the area for our rectangle part. And also, in terms of the triangle part, I'll use another color. The base and the height of the triangle are the A1, A2, and H of the trapezoid. So hence the area of the triangle would be I'll write it on here. Just 2 times A1H plus A2H, which can be also written as A1 plus A2 divided by 2 times H. Yeah, so if we look at this triangle, we know this part is A1, and with the height H, so if I draw it on the side, it will look like this. So I want to calculate the area of this triangle. It's just going to be 1/2 times A1 times H, which is same thing as A1H over 2. And same thing on the right hand side as well. I mean, on the right side as well. For this area, it has a height as H and a base as A2. And want to calculate the area of this part. It's just going to be 1/2 times A2 times H, which is the same thing as A2H over 2. Yeah, so we just add these two together, and that's what we got for the triangle part, and this is what we got for the rectangle part. All right. So from the figure, we can see that, I'll write this down. A1 plus B1 plus A2 is equal to B2. So which means A1 plus A2 is equal to B2 minus B1. Yeah. So from the first step to the second step, we just minus B1 on both sides. Minus B1. Minus B1. All right. So we can rewrite the area of the triangles in terms of B1 and B2 as triangles B2 minus B1 over 2H. And combining the formula for the area of the triangle and the formula for the area of the rectangle, we will have A is equal to B1H plus B2 minus B1 over 2 times H, which is also equal to B1H minus B1H over 2 plus B2H over 2, which is the same thing as, because for B1H, it is also the same thing as 2B1H over 2 minus B1H over 2 plus b2h over 2. So it's the same thing as b1h over 2 plus b2h over 2. Right. So simplifying further, we will get area is equal to 1 over 2 times b1 plus b2 times h. And let's write a conclusion there. So here's the formula of the area of the trapezoid is, we just copy down the formula above, 1 over 2 times b1 plus b2 times h, which b1, b2 are the two bases and h are the height. Yeah, so I think that's all we got for this question. And let's leave a comment there. b1 plus b2, right. All right. So our next question. It's asking what's the measure of J in the triangle below. Okay. So let's copy down the figure first. JLK. All right. So in this question, we will use law of sine, or maybe called sine law, to solve this question. So first, let me show you what that is. Put it in here. Sine law. Okay. So the formula is given by A over sine A is equal to B over sine B is equal to C over sine C. Alright, where A, B, C are the side and capital A and B and C are the angles. And yeah, so by knowing this, let's go back to our given problem. Let me just copy paste the graph. Alright. So for here, if we want to apply the sine law, it will be something look like this. So 17 over sine 102, which is equal to 10 over sine J. J is right here, which is also equal to K over sine K. Right. And for now, we don't need to deal with K over sine K because it's not useful to us. So let's just focus on the front part. And by applying cross multiplication, we will have 17 times sine J is equal to 10 times sine 102. All right. So we move 17 to the right hand side. We'll get sine J is equal to 10 times sine 102 over 17, and sine 102 is 0.9781, and over 17. So we have our sine j is equal to 9.7814 over 17, and this is equal to 0.57538, and we use the inverse sign on our calculator. It's just gonna be something like this. So sine inverse 0.57538 is equal to j, and we will get j is approximately it is 35.1263, which is approximately 35 degrees. Yeah. So j is 35 degrees, and that is our answer. So 35, our answer should be C. I'll just write it down this side. Yeah, so just remember, if you don't get a special triangle, just remember to use sine law or cosine law. Yeah. And by the special triangle, I mean is something like this. So if you don't get a 30, 60, 90 triangle, or another right triangle look like this, a 45, 45, 90 degrees triangle, always remember to use your sine law or cosine law. Yep. So let's leave a comment there. Good job. Okay. Oops. Well done. Okay, our next question. So what is 24 divided by 3? So multiplication and division are inverse operations. With that, we can solve the division problems from our knowledge of multiplication. So for the example 24 divided by 3, 24 divided by 3, we just need to think what multiplied to 3 will get to 24. So from our multiplication tables, and we know that 3 times 8 is 24. So 24 divided by 3 is equal to 8. I'll write this down here. So 24 divided by 3 is equal to, let's call it x, where we don't know what x is. So we just need to think 3 times x is equal to 24. And from the multiplication table, we know that 3 times 8 is equal to 24, which means x is equal to 8. So same thing, if we want, we just substitute back in there. We know that 24 divided by 3 is equal to 8. So that's the answer for this question. Yep. So yeah, I think these are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and the notification bell below. And if you'd like to submit your own question, visit the links in the description. Remember to leave a comment or like and share this video with your friends. This has been Andrew from OneClass. I hope to